All right, we'll see what that means in a bit. And so, yeah, at Nextjournal, we're solving this problem of writing reproducible research by actually building a time machine for science. And so if you search for advice on how to make your work reproducible, here's one thing that comes up. It's the 10 simple rules. And they go like this. For every result, keep track of how it was produced. Avoid manual data manipulation steps. Version control all custom scripts. It's this simple list of 10 items. It's really long, and it's really complicated, I believe. So it involves doing a lot of manual work, and this gets more complex with each additional tool that we use. And we see only a tiny percentage of papers out there today are actually reproducible. And I believe this is because this is way too hard. All right, so I believe scientists do need better tools to automate this work, something Brad Victor has been arguing about for many years. And it was his article on climate change that has been a major inspiration for us, which now brings me back to our time machine for science. So to achieve reproducibility, we need to capture state at all levels of our research environment and enable reverting back to previous states, so traveling back in time. Like for us as developers, Git is our time machine, but this works mostly for code. Probably everybody here uses Git and GitHub, and it's hard to ignore the massive impact these tools have had on software development. But for science, we have to consider more than just source code. So the ideal scientific research tool mixes prose, data, computational results, figures, what's commonly described as a literate computing environment. What you see here is a fully reproducible article in Nextjournal. To make this a reality, we need to enable time travel on several levels. So this has to work first on a language process. Then we have to consider the environment this process runs in. Next, we have to consider input data and results. And lastly, the document itself. So let's first look at doing time travel on a process. So this is an example from Jupyter, a tool that's popularized literate computing and brought us a step closer to reproducibility. So what we do, we start by defining a variable, and in the next cell, we make a change to it. So look what happens if I delete the first cell and re-execute the second one. So here in Jupyter, things are just running in global state on top of each other, which is why I'm now in this like inconsistent state. I'm missing the definition for X, and my document isn't reproducible anymore. And I'll only notice this if I restart the kernel and re-execute everything from scratch. And now I get an error like I'd expect. So this is a pretty simple case here, but as the document grows, this actually becomes a pretty big problem. Like I'm using somewhere down in my document, I'm reassigning a variable from up there, and I have to rerun my whole code from the top in order to get these results back. And here we look like how that works in Nextjournal. Like compared to Jupyter, which runs on this global state, here all code cells are running in isolation by default. So we do the same thing here, define a variable X, which is 1. Add another cell where we try to increment x. But in contrast to Jupyter, I now do get an error here. Yeah, as these are running in isolation. But I do need to access global state oftentimes, so you can explicitly change the scope a code cell runs in, so it actually does have access to the variables above if I do change the state like this. And now you get two like you would expect. But what I can do now also is, in the third code cell, I can use the scope of the first and still have access to that previous value of the first cell where x was still 1. And there's another thing, instead of relying on scope, to pass data around, you can also run in isolation and access values that other cells define. So here I'm changing the scope back to be isolated, local scope. And then I'm actually printing out the value of x. And now you see, if I do change the code of the first cell, I won't have to, like I'm making a code change that changes the code, but lets x keep the same value. So just making it 2 minus 1. And you'll see that the second code cell will re-execute, but the third cell, because the value is still x, is still 1, doesn't need to be re-evaluated. So here we are avoiding these inconsistent states. Users don't have to do any manual work. And yeah, you can imagine as this grows more complex, that saves a lot of work compared to like having to constantly stop and make sure like run on continuous integration to ensure your stuff stays reproducible for others. So how does this work? We use a relatively new kernel extension called checkpoint restore in user space to do a memory snapshot of the running process. We can archive that to disk, and yeah, that way we can go back to any previous state of a process. And yeah, as this is a kernel feature, this is language agnostic, so it works with all these imperative languages. Secondly, on the backend, we model each code cell as an Elixir GenStage process. And so these code cells form a directed acyclic graph, and using GenStage to subscribe to new values of other cells.
So before you talk more about the architecture, I'm just a little curious about so the stuff that you're showing us before, it's hosted, I presume, right? And then you have the stuff that you showed us before is hosted, right?
Yes.
So you have it, it's like you're offering this as a service, and then you have Julia and a few other languages, right?
Yeah.
And then now you're describing basically how the backend works, and but I guess my question is, how easy is it for you to add other languages, or is there some way for users to have like a version checked out locally or something that they can use so that, let's say I'm on a plane and I want to work on my paper, is there any way for me to execute some Julia code in my browser, like, on a plane? Like is it all hosted, or do you have some kind of offline capabilities?
Well, so yeah, we do work on a standalone version as well, but yeah, at the moment it's all hosted. But yeah, we've gotten that feedback a lot that yeah, people need to work on planes. Yeah, I think it might be something we do, like just to offer support to edit your document while offline, but the code evaluation might stay yeah, remote for a while.
I was curious what the serialization methods you use to pass data in between these.
All right, so yeah, so we have the Creo stuff as a fallback, like to use global state, and that's also like we do this because yeah, you can't serialize all objects, especially across languages. So yeah, for now we do like JSON encoding for some type of data, and for data frames we're using like Apache Arrow. This is like this column or feather based on Apache Arrow, which is this columnar serialization. Yeah, but this is actually something like we plan to have user extensible. So yeah, people can define their own coders and like yeah, define what tests or yeah, hook into the system and choose whatever they want.
So this looks pretty nice for some smaller or medium-sized programs, but what if my paper involves me forking some huge project and changing a little bit, and how do I run that big thing from inside the journal thing to get some results if I want to version them, or how do I call out to some external thing?
Yeah, that's something we're still figuring out. So yeah, I think yeah, that's certainly a use case we have in mind down the road as well. For now, we're focusing on this like stuff that works on one machine basically, but it would certainly be nice to run like molecular dynamic simulations or stuff like that, stuff that takes weeks and like yeah, have the capabilities to like yeah, stream data back to the platform and like watch your like also like automate these kind of tasks, like getting the data out there, starting this program, and get the data back again.
Yeah, sure. Is there a way to send data? Like I run the thing on my machine, okay, it's maybe not perfect, but I run my big simulation on a week on my server, and then I send the results to your...
At the moment there isn't yet, but
okay.
Yeah, we certainly want like such a document to have an endpoint, yeah, where you can get data back to it.
Cool.
All right, then yeah. Next thing to consider is the environment our process runs on. So what do I mean by that? Yeah, the reality is that most code runs on this shaky foundation of constantly changing the dependencies. So we have the operating system, system libraries, runtime, the language runtime, and packages. Like this problem is commonly known as dependency hell. And yeah, here just an illustration of how this works. So this is an article that uses the Yahoo API to plot Apple's stock price. We can get it to work. And so that API was actually, it broke like a month ago. So we had to install this additional package which works around the problem and fixes it. So here I'm trying to, like, because this is an isolated cell, I can just delete the package or the cell and remove the import here and test it, like reverting those changes of the installation. Like this is something like we're often having problems doing, like we keep installing stuff on our virtual machine, but we don't know what were the commands that actually what was the stuff that was actually installed, and how do we get back to this, get back to previous states, and what did we actually need to install for the stuff to run, and reverting, like installing a package often brings dependencies with it, which we also want to get rid of, and this solves this problem. Also saving a lot of time by being able to split up these into individual pieces of work as we choose, and not always having to run stuff from the beginning. All right, so yeah, this is made possible by file system snapshots. So yeah, we're using Docker to store immutable snapshots of the file system and archive them forever. And yeah, you don't ever have to worry about this. This just happens automatically. Also, hopefully saving users a lot of work. Next. All right. Yeah, then I'd look at time travel on results and data. And yeah, just to give you another example here, this is like a Python article that uses some data from NASA's OpenNext project, a prediction of the maximum mean temperature in Chicago for the next 50 years. And like, given this file name here, I can upload like new contents into that file, and without ever having to like fiddle with file names or anything, I can rerun that code, and it will, like behind the scenes, it does content addressing. So yeah, I don't have to worry about manually versioning those files. The article just uses a reference to that file, and I can also undo this again. Yeah, like I said, so data is automatically versioned and content addressed. So we've looked at like versioning the process, its environment, and its data. And the last thing we have to consider is the document itself. So what we do here, changes to a document are described as data, and we just keep that list of events that change the document and are able to deduct any state of our articles by operations in order. And so, yeah, like using this. I guess this, oh. All right. So here I'm able to go back in the browser to old versions of our documents. Yeah.
I'm curious, you talk about time traveling. What if, like, for example, I have a few people who collaborate with me on a paper, and they do some changes and they want to merge or something like that, which we're pretty used to from software development. Do we have some facility to merge or rebase, or I don't know?
So yeah, at the moment we do, yeah, it's just live collaboration. And yeah, this works on a per node level basically, and is just last write wins. Yeah, which actually works well in practice so far. And yeah, we want to do like next to operational transform to be able to support merges and forks.
Okay.
So yeah, like the GitHub pull requests workflow model is something we certainly want to have in mind here and want to support. So yeah, this time travel on the document is done using event sourcing. using ClojureScript's immutable data structures that make it feasible to do all of this in the browser. Any questions so far?
Questions about the future. So I ask them, and then he tells me what they are. So, how would you start? And then I start interrupting you because I have like 80 questions. So I want to give you a chance to actually say some of the things you have planned.
All right. So yeah, we certainly want to enable reuse and like rapid exploring of so not just have this available for the authors, but for the readers, so they can dig in and understand this data better as they're playing with it. And yeah, also to do more more complex workflows, like what we don't support at the moment yet is like, so these code cells can be seen as functions of their, like depending on what values from other cells they subscribe, like, yeah, labeled arguments of those values. And yeah, you could imagine calling those with other arguments. Yeah, if this was possible, like you could integrate any kind of, yeah, complex workflows you can think of. And yeah, like getting that to work and make it perform well is the tricky part, where we're certainly open to any suggestions. Also, like how to, like, we're trying to keep this, like the API to integrate languages as simple as and as open as possible. So like you can actually, like without any work, without writing any custom code, integrate any kind of programs that just like read data from files and process, like write to standard out and write data back to files. Just
Okay, I have some questions now. How do you export your notebooks? So let's just say, I mean, maybe I want a PDF, or maybe I want like a markdown file or something of like the current snapshot that, for whatever reason, I can't send a link. You know, maybe there's somebody who works at a company who has like restricted internet access or whatever, which is pretty realistic in a lot of industries. So I want to send somebody my results. Like, how do I get something out to give them?
Yeah, so we just, at the moment, we just do, like you can get a JSON out of our, yeah, just, this is just this tree of the nodes, but yeah, we definitely want to support exporting to LaTeX.
Yeah, exactly. Like you can't separate academics from, or PDFs from academics. It's just impossible. I mean, I don't think that most people outside of academia find PDFs particularly like practical. However, you know, nobody reads papers so much like on blogs or anything anymore. I mean, there are many HTML versions of lots of articles on the internet, but most of the people are still downloading PDFs to read them. So, I mean, if you're going to export LaTeX, awesome. But then the next question about exporting LaTeX is that people do horrible, crazy things with LaTeX, where they try to do ridiculous formatting. Or let's say I like to do type theory, so maybe I have some inference rules or something. Like, that's going to be hard then to import into your system to actually put in the notebook, because you have to use some special LaTeX package for that. So I guess my observation, which is kind of half an observation and half a question, is you know, are you thinking very much about trying to make this notebook play nice with LaTeX in case I want to actually make a notebook with my typing rules, for example?
So I think what we're focusing on now is like actually like generating the results easier. So I probably see this more used as like generating supplementary material to your work than like replacing PDFs for people. And yeah, so I also think like that, yeah, it's difficult for like to always get this PDF representation.
Hey, thank you for showing us this stuff. I'd be keen to re-examine the premise, because I think there was a list of stuff that you said was hard, And I guess my reaction would be, like, version control is not hard, and there's a bunch of other stuff that doesn't seem that hard. So I wonder if you could explore some of that, because if I'm a little concerned. My gut reaction is that this is like a bad abstraction, and that sorry, this is really pejorative, but yeah, I'm nervous that you're kind of closing a lot of stuff off and centralizing things, whereas an open system might be a bit better for this, and might get a bit more pickup. But yeah.
Yeah.
Sorry.
So yeah, I think it's like as we're crossing like different tools. Yeah, it's like in the stuff I worked with. I did my diploma thesis in like bioinformatics, and so I went into this group, and like every student that comes there has to figure out the stuff from scratch again. And I think like compared to if you had good ways to automate these processes, like you could save months of work for every new person joining this team. And also like all the knowledge that is created, like it lives on these people's machines, and then when they're gone, it's gone again mostly. So I think there is a big problem that needs to be fixed. I do know that like a closed system can't be the answer.
I noticed that it shouldn't live on their machines, but now it's going to live on your machine. It feels like,
no. So one idea we have about that, yeah. So as these things are immutable and content addressed, like distributing them is pretty trivial actually. So yeah, some projects we're looking at is, for example, IPFS, this distributed peer-to-peer file system. And yeah, we certainly we don't want to lock people into the system. We want to provide value for them by like ensuring things are running smoothly, that you can run your computations then, and you don't have to worry about manually ordering servers or shutting them down again. So we want to save people time and money, but yeah, don't want to lock them in. And like we certainly plan on open sourcing this stuff, but at the moment we're still moving pretty fast, and we're not ready for it just yet.
Hi. So I have like a more general question, I guess. Maybe you've kind of already answered it, but so the whole premise is reproducible science, I guess. So what if I have some sort of code that somehow accesses the outside world? Like, for example, just it uses the current date or something. And how can we make such things reproducible?
Yeah, so, or what do you mean by making that reproducible in that case?
Well, I thought the premise was that we always want the same results. So if we run some arbitrary code, we should always expect the same results, right?
All right. So
yeah.
I mean, these are languages that like you can do any kind of side effects in those code cells. Yeah, and yeah, we're not going to stop that. So what we're doing, we're chopping this up into tiny pieces. So compared to always having to run your stuff from top to bottom, and like in your first cell, your installation of a package breaks because this doesn't exist anymore. You can choose to run these cells, rerun these cells, and individually. So yeah, you can choose where to enter in your document. So cutting up this problem a bit into pieces, and like one of the projects that actually, one second, a slide without much information on it. So yeah, this is actually something that functional package managers look at addressing. So like there you have these actually help you to, like, for pretty much everything you've seen in the dependency hell graph, from system libraries to the language itself to packages in that language. These functional package managers help you to build your stuff in ways and ensure that this is actually reproducible on a bit per bit level. So this is one solution to the problem. We're playing around with this at the moment, and it's quite encouraging.
Hi.
Hey.
I was thinking about Nix a bit, so I'm glad that you went to this slide. So what I'm wondering with respect to Nix, you said you were, you just said you were thinking about it. I'd be interested to, sorry, I'd be interested to hear about your thoughts for making Nix or Gwix easy to use. Because I imagine, so I run my system on Nix, and it's certainly not user friendly, and I think most researchers writing papers don't want to deal with it.
I think so. What should happen there is both of these systems have these like a global store of content addressed packages, which is also append-only and has some like pretty nice consequences of stuff you can do if you have that. So with Gix, there's also like running only free software. So to make this work nicely for a lot of stuff, like people want Conda, people want to compile stuff with Intel MKL, and to make this work nicely. So on the one hand, you have to provide substitutes, so binary packages, so installation is fast. You don't want to always compile stuff yourself. And for making this nice to use, I think there should be just an interface where you select a package. If you don't specify the version, it will use the latest. But then it will know what that version is at that point, and you'll always be able to get to that environment. And this should also, I think, happen behind the scenes without the users having to deal with this, as you say.
Hi. Have you maybe looked also into like a more general question, maybe like how could you, with a kind of a minimal product, improve the situation that you found yourself in the bioinformatics department, but maybe also in other departments concerning this reusing of knowledge and kind of tracking what's going on? Because I've also looked at into this space a bit, and I saw some efforts from Ward Cunningham, I think, where he is trying to expand Wikipedia to a more federated situation.
Mm-hmm.
I'm not sure if you've heard of
No.
that. I was just wondering, like, this seems like a very fruitful approach for like a programming perspective, but maybe there is a more general question of versioning stuff, and that could help a lot of scientists in general to have more reproducible results on a more like basic level. Because I can imagine that lots of people just work in Word documents, and that's spread all over the place. Like, is there like a minimal? Do you have an idea about that, like a minimal approach that could would be useful by a lot of people, but still would improve the situation?
I think like something like IPFS, or are you thinking now more on the document side, or so IPFS is this like peer-to-peer system for storing files, and so it's using a lot of different concepts underneath. So it's actually this this Myrtle, is it Merkle tree or Merkle deck. So similar to Git. So you have content addressed files and cryptographic hash. Because of cryptographic hashing, you don't need to trust any of the peers. And yeah, on top of so you can very easily store a file system tree versioned in it, or can think of storing documents in it. And also establish trust, using this cryptographic hashing, you can establish links between those things that never break, and each user, each peer can choose what files he wants to keep in his system. This is called pinning. Yeah, so this is one general solution I can think of. But yeah, from a document side, I don't know anything.
So I actually wanted to follow up on that, and I'm sorry I'm going to keep being annoying about LaTeX. I'm so sorry. But so this is one way I think that, for example, you could reach a whole broader swath of fields. If, I mean, maybe not just LaTeX, but if you wanted to typeset, better typeset, use some special LaTeX package to typeset some math in a special way, then basically you target all of the math community. And perhaps they want to show, let's say that there's some math that generates a certain, I don't know, plot of some kind that's interesting. I mean, they could then do this both in the same window, basically. You could typeset your math, and then you could show some interesting drawing that math generated, for example.
Yeah.
And I mean, you could have both the math and then the code that generates that, which is exactly reproducible, right?
Yeah.
So I don't know. I mean, I know I'm freaking out about LaTeX, but seriously, most of the science people on the planet are glued to LaTeX, except for the physics people. They do things in Word for whatever reason. But on that point, though, I think you should really, really super consider more LaTeX, reusability, basically.
Yeah. So formulas we do support. Yeah.
It's way more than that.
Yeah.
People have special typesetting for every little different thing.
And you think they need control on that level?
Yeah, everybody has their own special package that they import for their special thing.
All right.
Hi. About IPFS, how can you do to make sure a document you store in it will keep available even if your hard drive crashes? Can you do something for this to say, okay, this document, I'm pretty sure it will stay available for some time?
So how to keep data available as it crashes, or?
Or available over IPFS? Or is there something like this?
Well, yeah, so you can, each node in this cluster can choose what files it wants to store. And I believe there's a project called IPFS cluster where you can configure, I want each piece of data to be stored on at least 3 nodes or something like that. And yeah, it also does, so it's this distributed hash table that does the routing to the closest peer. So yeah, if you want to move big pieces of data around, it would always collect it from the nearest peer. And yeah, so I think this is a pretty interesting thing for science.
So I have 2 comments. The first one is echoing the people before who talked about closed systems and federation. So in your answer, you talked about a way to share the file and encrypt it. I want to ask again about federation and open source. Oh yeah, you did mention open sourcing. So would you consider, after you do open source, the web app that puts it all together, making it easily federated so that you can have distributed systems, and I can spin up my own server running the code on my local machine and have it, and I can then use the app without having to have internet, or then it wouldn't be a closed system and that kind of thing. And if you do, consider like making a package for Sandstorm also, which is a thing that my friends made, and it's sort of like it's the purpose of it is to bring the like promise of federation and decentralization to the open web. Like we all want decentralized things and to spin up our own servers, but like ops is hard, so it like does the ops part as a service. But and the second part was it's sort of like using LaTeX as a platform with like all of your plugins, and then this is like a platform for that platform and many other things, and then that made me think of the browser. So like, is it like a LaTeX browser that you're looking for, sort of like, or I guess this is sort of what that is, but anyway.
Yeah. So yeah, the standalone, making the client a standalone thing that works on its own is certainly something like we want to do, and we just want to get to a state like we're still changing our document model around, and I think within the next few months I hope we'll stabilize that and also be in a good position to open source that, and like down the road I see us being more of an infrastructure provider than like offering the software. I think this should be something, people should be able to run this on their local machines, and then this Sandstorm project, I think this was something I came across as well. I mean, there we're considering our options currently, like if we use something like IPFS or I believe as this stuff is like content addressed, like sharing it and transferring it into other systems shouldn't be so hard anymore.
I think we are out of time. That was a pretty nice discussion. Thanks a lot to Martin.
Thank you.